So it looks like we have a new arrival
A new arrival
from
from the Digibarn Computer Museum. Bruce Damer.
Hello and welcome back. If you have been following the channel for a long while, you might remember that a few years ago we started the restoration of our second Xerox Alto, which came from Bruce Damer's Digibarn. But as the name implied, it was truly a barn find. It had been inhabited by barn critters and was even containing nuts. You can see, a tough life. Whoa. Ethernet card. Yeah,
I have photos
coming.
from the Alto.
We gave it a good clean, removed the nuts and repaired the chewed up cable. When we tried the power supplies, we discovered that all four of them were bad. Restoring the main supply was a real fight. I had never seen a switching power supply with that many failed components in it. Caps, diodes, voltage regulators, resistors, transistors, fan fuses, everything had blown in that thing. But we eventually prevailed and got it to work. 50 amps, 4.98 volts. The portrait display screen was another head scratcher. It wasn't even from an Alto screen. It came from a later device, maybe a Dolphin or a Dorado, and had a completely different interface circuitry and plug. We converted it back to an Alto configuration, but when we turned it on, nothing came up. Using Carl's high voltage probe that had been stolen from the Star Wars prop department, we found that the high voltage was missing. Turns out that a simple light bulb, used as a regulator in the high voltage circuit, had a broken lead, which shut the whole thing down. When we changed the bulb, it came back to life, and to our surprise, the tube was very bright and crisp, much better than our very tired one in our first Alto. The cabinet did not appear to be a legit Alto cabinet either. It was missing the slide rails. Some cables were missing too, even one board was missing. So we made new rails and cables, added the missing card, but at this point it dawned on us that this might never have been a functioning Alto. It came from former Xerox Alto repair technician Ron Cude and appeared to be just a pile of his bad parts collection, thrown into an Alto-looking configuration. Even the disc had a sticker that said "smoked" on it. We tried to boot it up, found and repaired a fault in one of the boards, but that still did not help. At this point we expected that each of the boards would have multiple failures, and unfortunately we did not have the time to take on such a large project. That's when Josh Dersh stepped in. Josh is another computer restorer extraordinaire, a professional one at that. He used to work for the Living Computer Museum in Seattle and had written the Contralto emulator, which we had used extensively in our restoration. We exhibited next to each other at the Vintage Computer Festival in 2017, and we were able to network his emulated Contralto with our real restored Alto and play Maze Wars over the network. Josh also has a functioning Alto in his very extensive private collection. He took each board from the Digibarn Alto and worked on them until they would boot in his own Alto. We reached Josh in Seattle via Zoom.
So Josh, thanks for coming online.
Yeah, no problem.
So you're in your lair. I see old computers behind you.
Yeah, it's kind of a mess down here right now. But this is my basement. This is where I work from home here, and I do my computer hackery here, and so I just have.
Oh, I see an Alto working. The Alto is
have-
up. It's waiting for us.
Yeah, I have an
Oh,
Alto
you're
over there set up.
You're prepared.
I always prepared. Yeah.
And Josh, we started working together when you were at LCM, and then you had written that incredible Alto emulator that emulates the Alto down to the microcode level, which can use extensively to figure out what the Alto was doing.
I'm glad it was so useful.
And then we kind of half repaired the Alto that Digibarn had loaned us. We really cleaned it up. We redid all the cables. We attempted to boot it, we thought this was never an Alto. This was built out of broken parts, basically, that were piled up. So we gave it back to Bruce, and then I think it fell in your lap.
So what happened was last year in February, I actually got my own Alto for my collection here, which you saw in the video. In March or April, I spent some time restoring it, and it was actually a pretty easy restoration apart from the 5-volt power supply. The only fault was an IC with a broken leg, and that was pretty much it. And after that, it pretty much came to life, which I thought was pretty fortunate. So what I ended up doing was, since I had a working system and Bruce, had wanted to get his system running, and I had him send his boards up here, and I figured the strategy would be, since I have a working system, I can swap boards in one at a time and see which boards have faults on them, and then work to isolate those on a per board basis. I kind of brute forced it, honestly. I had previously built one of these. This is a Tontec IC tester, which is just a simple kit. You can get it for about $60. And due to the Alto having all of the ICs socketed, what I did is I took the ICs out to inspect them and clean the legs. And while I was doing that, I tested them in the IC tester.
Okay, so you didn't use a logic analyzer at all?
I didn't end up needing to do so. It ended up being mostly brute force. I have a box here of all of the ICs that I ended up replacing.
So how many were bad in the thing?
Let me see here. There were a total of 32 integrated circuits that needed to be replaced, and 6 sockets that were marginal enough that they weren't making good contact. I don't know if you can see the group.
So those are the Swiss turned contacts.
Yeah, they're really nice, sockets. Except that you can see this one that's supposed to be gold and it's pretty green.
It's corroded. Yeah.
So how long did this whole process take you, brute forcing through every chip?
Just over a week. But you can see some of the ICs like this. The TI chips. The legs on them tend to corrode very badly.
Yeah, they become black. Yeah,
they become black, and you can see this one had a leg fall off. I would say I think I ended up actually replacing just about every TI chip in the system, either because one of the legs had fallen off, or it actually tested badly. Let's see here. There were 74109 chips on the Diablo controller. I found one bad one. Replaced it. The drive started working properly, and ran for about a half an hour, and then it failed. Pop it out again. I find another 74109. That's bad. Runs for another half an hour. Fails. I do this 2 more times, and every time it's a 74109 from the same week and year of manufacture. And at that point, I'm like, I'm just going to replace all of these 74109s.
What's the 109? A driver or?
It's a flip-flop.
Oh,
yeah.
The flip-flops are particularly bad. I get a whole bunch of 7474s. I think the flip-flops are more complex than the regular TTL, so they're pushing the limits a little bit more.
But when I've looked at flip-flop circuits, they tend to use like weird circuits, depend on voltage levels in unusual ways, and they're not just like your standard logic gates. So I'm not too surprised that they'd be more sensitive to things going wrong.
Yeah. And that was pretty much it.
Well, it looks like you were much smarter than we were, because we did it the hard way, trying to find the fault in the machine.
I feel like I feel like I cheated, honestly, but it did the job, and it could really, having obviously a baseline working system to test against helps immensely.
Right, we didn't have that either. Right, we were trying to get our system, and fortunately our system didn't have that many bad chips in it, and then we had a mismatched card. Actually, we wouldn't have found the fault without the logic analyzer. And then
in that particular case, you definitely want to, starting with a logic analyzer and actually working that way makes a lot more sense.
Right.
In this case, given the system's reputation being basically built from known bad parts, it seemed to me anyway to try it from the other way. After I get everything running, I think I let it burn in for about 8 hours. while during the burn-in process, I did have to go through and replace a couple more ICs.
Yeah, well, thanks a lot. That saves us a lot of time, and it was very efficient.
This had all taken a very long time, 3 years actually, but today we are visiting the Digibarn, where the Alto has been fitted with all the repaired boards from Josh. The Digibarn is nestled deep in the forest of the Santa Cruz Mountains. Looking for Bruce, we went past the barn and discovered his newly built Gandalf house.
Okay, well, we were coming down to look for you guys.
Okay. It's beautiful. Did you design that?
Before? No.
Because I don't remember it.
I built it from 2018 to 2019 with help from Weta Workshop in New Zealand.
How did you ever get involved with the Weta Workshop people?
I was doing science in the North Island. I work on the origin of life, and he said, "Hey, Richard Taylor wants to meet you." So I flew down. He's the founder of Weta. Flew down and brought him the stromatolites from Australia, 3 billion year old. So I wrote to them as a joke, "Do you happen to have the plans for Gandalf's house?" And they said, "Well, he didn't have a house, but he certainly deserved one." So we designed this together with the Weta folks.
But let's go back to the barn, which I had never visited before.
As it usually is with all these machines.
Bruce has a large collection of unusual machines, some I had never seen or didn't even recognize. Of course, the ASR33 I know of. But this one, it's an IMSI, but that looks like a full computer. There's also an assortment of Apple devices. Some are actually prototypes, some DEC machines. Here's another Macintosh. The occasional tech screen and mechanical calculators. This early Wong computer or calculator, whatever you want to call it. A beautiful and large analog computer with a built-in screen in it. But wait, he even has cranes in his barn.
That was the prototype for the Cray 2. And it was at Minnesota Supercomputing Center. And they built 2 of them. One of them was destroyed. And this is a trade from the Supercomputing Center there. Cray 1S, serial number 38. So it was at Lawrence Livermore. And they had 4 machines. And serial number 6 is the one at the Computer History Museum. And it's the one that was in the movie Tron. But just, you needed like a full-on $100 million facility to run one of these.
Because you couldn't get enough electricity from the grid?
No. It's 3-phased, 240 phase or something like that.
So
and these are rated to 150,000 amps.
And this very rare Link computer from the MIT origins of digital equipment.
Yeah, so this is the Link that we restored in 2007 with the original Link team. So there's their signatures. And of course Wes Clark is gone now, but Severo Orenstein just moved to Santa Rosa.
This is the computer, and this is just the pretty face of it, the terminal?
Yeah, these are the terminal, front panel, modules and data.
Oh, I didn't realize that. I always thought this was the computer, but no, it's here.
It's here.
And finally, in the very last room, here was our Alto waiting for us, now filled with cards repaired by Josh.
We shipped all of the boards to Josh, and he replaced all the dead chips, tested it in one of his Altos, and they all worked. And so then he came back down, and we reinstalled the boards with the wonky power supplies you know so well, Mark.
Yeah.
So our first task was to convert the screen back for Alto use again. We had given it back to Bruce in its original Dorado, or whatever it was, configuration. Fortunately, Ken still had his conversion cable, and we still remembered how to hook it up, or so we thought. I'll have to rely on some vertical iPhone footage from Bruce, as I did not catch everything.
I also have David Boggs' little Ethernet debug thingy.
Oh, that's for Dave Boggs?
Yes.
How cool is that?
Yeah.
He's still in the game.
Well, he brought it into his box of goodies. Can we keep it?
Right.
Okay, so here you go. If you can plug that in. For us. That's the monitor we repaired, right? So
do you want the monitor plugged in
That's
too?
the monitor you repaired, yeah.
I guess so.
We're going to plug it in?
Yeah.
It's on Ken's authority.
He's
Yeah,
gonna
be
Plug this
careful
in.
right next to your foot.
Yeah, I don't want to step on the widget.
Right, and then if you turn it on, it either smokes or it works.
I heard a nice thunk of power going into. Gotta wait for that filament.
Filament heat up.
Yeah, I see orange glow.
I don't see anything. Can you make sure the brightness is up? Towards the left. Okay, no cigar here.
No. And
Okay, so gee, and then we're not equipped to test high voltages.
You've got a finger.
Well, again, we could bring out the scope and figure out if we get the flyback. I don't hear anything.
we don't have the manuals here. You disconnect from this cable and see that in case you're like,
Yeah.
So it's not starting too well. The Alto monitor is weird. It does not start up unless it receives some unusual sync signals. But we were using our little red tester here that provides these, so it should have come up with stripes on the screen. So I brought out my oscilloscope to test the tester, and our tester turned out to be bad. So we opted to hook the screen up directly to the Alto. Without a disk, the Alto would not boot, but if the graphics card worked, it should send the sync signals and we should get a blank screen.
I try it again.
okay, CRT's on.
Arms on.
We got lights all but one.
Oh yeah, it turns on. Face our
And the monitor is working.
What do you have on the
Well, white. It's all
Oh, look at that!
We don't have a cursor though.
Yeah, because we didn't boot anything yet.
Okay, so monitor's going. Alright.
Promising.
So remember, the disk drive for this Alto is smoked, so we can't boot it normally from the disk. But Ken has a trick up his sleeve. He had engineered an Alto network emulation contraption, which included a remote disk server written by Josh.
Okay, so this
If we hooked the Alto Ethernet port to it, we should be able to network boot the Alto off Ken's emulator.
my board is working at least.
Oh, okay.
My part works in all this.
Well, it's all Ken so far. It's your adapter to the monitor,
This Ken's adapter, the widget.
and then the Ethernet.
Are we ready?
We are. I am.
Monitor on. Monitor's coming up.
Okay. All right. So we have 3 power supplies good and 2 bad, but those are for the plus minus 15 for the disk, so we're not so worried, except if they blow smoke.
So now we just have to remember the magic key sequence for the net boot.
a reset?
Backspace and double quote, and then I push and hold,
Then
push the button in and
push the button, release it, and then keep your fingers on the keyboard for 5 seconds. And is anybody watching?
it's a stronger beat, it's stronger flashing.
It's doing some
Yeah, it's packets.
Okay, well,
Do we have a cursor?
You do? Oh yeah, yeah, it's booting.
Oh, look! Xerox Net Executive.
Boot it.
13. Yeah.
Turn the brightness down, Carl, a little bit. It's too high. There we go.
How wonderful this is.
All right.
Success.
Booting achieved.
Our work is done.
There it is.
Well, that has been quite a rescue.
This is so good, guys.
What an operation.
so type the name of one of them to execute it.
Okay.
So like, I don't know, try
Asteroid. Astroroid.
Okay.
Astroroid.
Okay, and then hit return. It's
Oh,
Doing
trying to boot
something.
something. It's booting.
Read scores.
hit end.
Play with saucers.
Why?
oh, that's promising.
Hey, there it is.
Okay.
Yes.
Game's on
Oh
screen.
my god, amazing!
And then it's those. I can't remember which keys. It's this. Yeah, this one, that one, that one.
Space.
Space
Oh, we lost.
asteroids.
Okay, let's connect the mouse. This is the first iteration of the ball mouse that would become familiar to all early Macintosh and PC users.
Firing, firing, firing. I'm about to get nuked. Oh, there we go.
Ooh, oh, you almost got out of
Look
it.
at that.
Wow, look at that monitor fade. That look good? The
That
monitor
monitor's-
fade.
That's great.
Wow. This is a 30-year dream, guys, come true right here.
So without the disk, you can only run a limited set of programs. because a whole lot of things try to access the disk, and then everything will just go
Gotcha.
bad.
This is Ken Sharif who made the widget. Trek. Oh, that's a good one.
Well, I could return.
Here it goes. Okay.
Wow.
Oh, I've never tried that.
Trek. So you click there to hit the planets.
There's a mouse pad.
There's a George
But
Pate.
there's nowhere to put it.
There's a George Pate mouse pad there. Wow. Track to winner. Let's go down here and see. First mouse. Well, the first one was on the SRI computer in 1967. There's our little Star Trek ship. Okay, did something to it.
Alright, mouse kind of setup works, good enough to play Trek. Let's hook up the chord set. Probably the only one of the brilliant Alto inventions that did not make it to the modern age. I had repaired this set for Bruce a long while ago. Okay, I tickle the key set. It works.
Yeah, Bill English, when he demoed on the SRI key set, he said I could type like tens of words a minute on it.
It's really one of the very few things that didn't make it, right? Almost everything else did it.
Everything else did it.
It was
The
a
graphic-
peripheral invented by a musician, not a general computer scientist, and it made sense to musicians like to you, but not to anybody else.
I don't think it makes sense to anybody, but
I'm tickling the keys.
it's spaced like piano keys, and it's
Maybe 20 years from now it'll suddenly become popular. But it's amazing how much they got right on the Alto. It's like the spreadsheet is about the only thing they didn't invent.
right. So it took a long while, but thanks to Josh, we finally revived the Digibarn Alto and have a very happy owner. Here we pose with the Alto displaying a picture of Dave Boggs, the engineer that invented the first Ethernet card and gave me his little tester. And here's our happy owner again with one of Boggs' original Ethernet coax transceivers. So that was our long overdue happy ending. See you in the next episode.